Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out rational numbers and what on earth rational numbers are. We're in the Common Core Math standard of the number system, and we're going to be dealing with knowledge and understanding of fractions, adding and subtracting, multiplying and dividing them eventually, and with rational numbers. Let's do it. Got our guiding question today of where and how do we use different kinds of numbers, and especially with rational numbers. Where do rational numbers come into play in real life? All right. Here are a whole bunch of boats, and you can imagine that you put all these boats together and the amount of specific lengths you might have of the cords that are coming down, of the rope, the thickness of the ropes, the thickness of any of the metal, and any of the bars there, and all of these are most likely rational numbers. When we get down to it, most of the numbers that we look at, if we're going to be measuring things in real life, they're not going to be nice numbers, like the thickness of this rope is 1. No, the thickness of the rope is probably 1.112 or something. All right? And that's a rational number. And rational numbers are all over the place. Think about where you could find rational numbers. Maybe in the spacings of the boats, in between the two boats, or the temperature of the water, or how much money this car cost. All of those numbers are most likely going to be rational numbers. All right? Here are the different kinds of numbers that you have probably seen. I know you've seen integers, right? Fractions and decimals, looked at those in the past. Whole numbers, most definitely. And now we're going to talk about rational numbers and what on earth rational numbers are. All right? So here's our number line. Let's talk about where we fit all of these different kinds of numbers, okay? What numbers fit here? What kind of numbers fit here? Between 0 and 5 and so forth, and getting bigger. Out of those options that I gave you before, what types of numbers go here? All right, well, if you said whole numbers, you're correct. That's exactly right. What about here? What kind of numbers are these? -1 and -4. What are those examples of? Those are examples of integers, positive and negative counting numbers. What about these guys? The numbers between these two numbers, between 0 and 1. What numbers are those? The numbers that are between 0 and 1 are fractions and decimals, something like 1/10 or 0.26. Right? Those are fractions and decimals that are in between 0 and 1. Now, rational numbers would be them all. You put them all together, and rational numbers are them all. So let's talk about them now. Numbers can look different, but they can actually be the same thing, right? If you think about it, rational numbers are numbers written as a fraction. It's a ratio. Notice the word ratios inside of rational. So rational numbers is really a number that can be written as a comparison. So first we need to talk about what a ratio is, which is a comparison of two different numbers. Might need to know that. All right? Think about it this way. How many siblings do you have compared with how many cousins? Right as a ratio, as a fraction, as a decimal. Well, let's just say I have 2 siblings compared with 4 cousins. All right, so if I was going to write that as a ratio, it would simply be 2 to 4. That's my ratio. Write it as a fraction. Well, you take the left number, put it on top, and put the 4 on the bottom. And then that's 2 over 4, which equals 1 over 2, which equals as a decimal 0.5. Okay, so that's how you do it. And then to turn it into a decimal, you guys know how to turn a fraction into a decimal, right? Just divide it out. Okay, that's pretty much it for that guy. All right. Here's another example of 6 siblings to 8 cousins. 6 to 8, 3 to 4, 6 eighths reduces to 3/4, and it's 75 hundredths is the decimal. So rational numbers. What on earth are rational numbers? Let's do that. Let's get our formal definition here. Well, rational numbers are numbers that can be written as a fraction or a ratio, such as A to B, A compared to B. Okay, let's get some examples. Here's some examples. All these numbers can be written as a ratio or as a fraction. 1 to 8, -10 to 1, 1. Well, what number would be underneath the 1 there as a ratio? Well, just 1. Any of these numbers, like -10 compared to 1, -1 compared to 1. Put them all to 1 and you'll be good to go. Anything with an ending decimal or a decimal that repeats itself, those are examples of rational numbers. Okay? They don't have to be written as a fraction in order for it to be considered a rational number, okay? Here are other examples, something like the square root of 2. What times itself gives you 2? 1.4 something. It's not a nice number, just like 5.5 repeating is a nice number because it actually repeats. Or this one repeats, 6.3. And we can get pi in there, throw some pi in the face of a rational number because it's not. Square root of negative 1 is also not. So that's the idea. All right, remember what a Venn diagram is? Well, what I'm going to have you do now is fill out each appropriate level with the words whole number, integer, or rational number, and I want you to give at least 4 examples that would go in each circle, okay? So where are you going to put whole number, where are you going to put rational number, and integer? I'll give you a hint. Here. Rational numbers include more numbers than whole numbers or integers. Okay? Rational numbers include more numbers than both whole numbers and integers combined. So what goes in the middle? Here, here, and here. Remember, rational numbers encompass all of them. So rational numbers go up top. Integers goes there. And then whole numbers goes there. Whole numbers actually is the least amount of the 3. If you think about a number line, it's only the right side. Integers is the whole thing. And rational numbers is everything, even including in between the integers. All right. Well, let's talk about how we convert numbers here. Think of the division symbol, this guy, as a fraction. There's a number on top, a number on bottom. Bam, the numerator's on top, the denominator's on bottom. Okay? Think of that as a fraction. Well, first of all, let's do this. We want to turn a fraction to a decimal, so you need to know this. How do you turn a fraction to a decimal? We're going to divide. How do you turn a decimal to a fraction? Well, you put that decimal over a power of 10 of how many numbers you have there. And then, of course, you're going to simplify. You're going to always simplify your fractions. You always want to do that, okay? Never forget that. So let's do this. Let's convert a fraction to a decimal. This one's kind of easy. Well, we got to put the numerator inside the division box and then the denominator on the outside. Remember this, numerator inside. Both have that N sound at the beginning, okay? So what we do is to convert 1/10, 1 over 10, we put the 1 underneath with a dot and a whole bunch of zeros. I can put as many zeros after the decimal point as I want, as long as there's no other numbers there. And then I'm going to put 10 over there. So what do? Keep dividing. 10 goes into 1 0 times. Now, 10 goes into 10 one time. And then 1 times 10 is negative 10. Gives me 0. And that's it. So 1 over 10, 1/10 is equal to 0.1, or 1/10. Okay? Now, let's convert a decimal to a fraction. We're going to start with negative 1.4, all right? And remember, the hint is there. If there are 2 digits, we put it over 10. If there's 3 digits, 100, 4 digits, 1,000, and so forth, okay? So for example, we put 1.4 over 10 because there's 2 digits. We divide it by 2, divided by 2 because you want to simplify, and bam, you get negative 7/5. All right, or negative 1 2/5. All right, let's talk a little bit more about terminating and repeating decimals. Terminating decimals are such that they're decimals that actually end, and they don't continue on forever. It has actually a last decimal place. Like these guys. Let's look at these examples. Even though this is long, it still ends. It stops at 9. This is short, super short, ends, and this one ends. These do not. These are called terminating. These repeat, these numbers repeat, those repeat forever. So that one is called a repeating decimal. Okay. It's a decimal that continues to repeat forever. It continues to repeat forever. So non-example, actually the examples would be something like this because it repeats the 5, 5, 5, 5, 5, 5, 5. Whereas here, this repeats just the 9, so it's 3, 6, 7, 8, and then it's 9, 9, 9, 9, 9. And then this one only repeats the 6 and the 7, so this 6 stays the same, 6 and 7 repeat, and that's it. Those are called terminating decimals. Both of those are called rational numbers because they both can equal a specific ratio. All right, and notice I didn't draw any lines over these guys. All right, once you work through these, write some decimals as mixed fractions. I'm going to classify these numbers over here with as many different categories as you can. Tell me whether these are terminating or repeating, and turn these numbers into decimals. Remember, divide them out. All right, here are the answers. All right. Got any more questions on this? Definitely go back in your notes to see if you can figure out how to solve that problem. All right, where are you at with this question? Where and how do we use different kinds of numbers? Any idea? Bet you can answer that question now. All right, well, that's it as we talked about rational numbers today. Thanks for joining us. This is Matt with MathsMath.com. Check us out on Facebook at Solving Maths Problems and on Twitter with Maths Math. And enjoy math.